Today we will continue with rationalization. Remember, rationalization is a mathematical process we use to eliminate radical from the denominator in an answer. In this case, we will see specifically when we have a binomial denominator instead of a monomial denominator that we saw on the last video. It's going to be almost the same structure, but we will need to multiply by something a little bit different. Remember, of course, it's going to be the same in the case that we need to multiply both numerator and denominator by the same term in order not to modify the original expression. But in this case, instead of only completing the root like in the monomial one, in this case we need to multiply by the term or by the terms, because it's going to be more than one, that completes the product of the sum and difference of that binomial. Let's understand why we cannot only multiply by something that completes my root. What happens in this case if we only multiply by something that completes my root? Imagine I'm only completing the root and I only multiply by the square root of x. Because if I multiply by the square root of x, of course, on the first term, it will be 3 outside, and on the inside of the root is going to be the square root of x multiplied by the square root of x is going to be the square root of x squared, and it will be possible to get out. But remember, this one, it's also multiplying this minus 3. So if we multiply only by this, of course, the square root of x will be eliminated here, but it will appear again here because minus 3 will multiplying only the square root of x. That's why when we have a binomial, it's not possible to multiply only by the term that completes my root. And in this case, we need to complete the product of the sum and difference of a binomial. Remember, it's exactly the same but with different signs. The one that it's positive or negative is going to be one that it's positive and negative on the two, and there will be one that do not change sign. Remember, the one that we have on the top and the denominator, we will put it also on the numerator on top. So what will happen here? It's going to be in the bottom part, we will have, and I will do it in 2 steps because explanation purposes, 3 that multiplies 3x plus 3. On the bottom part, we will have 3, the square root of x minus 3, that multiplies 3, the square root of x plus 3. What happens on the denominator part? We have a product of the sum and difference of a binomial. What's the answer for a product of the sum and difference of a binomial? In this case, remember, when we have a product of the sum and difference of a binomial, it's the first one squared. So it's going to be 3, the square root of x, all of it squared, minus the second one, or the one that changed sign, squared. And on the top part, of course, it's going to be easy because we can multiply this by this and this. And it's going to be 15 that multiplies the square root of x plus 15. So what happens next? On the denominator, it's going to be 3 squared is going to be 9. If we square the square root, we can eliminate the square root with the power of 2. So it's going to be 9x minus 3 squared is going to be also 9. And on the top part, we have 15, the square root of x plus 15. It looks like maybe we have finished, but maybe we can simplify it a little more. Why? The two of them are divisible by 3. So if we take out a 3 here, so it's going to be this 3 with this 3, we can eliminate it, and it's going to be 5 that multiplies the square root of x plus 5, all of it divided by 3x minus 3. And that will be my final answer. So it's a process that is kind of similar than when we have a monomial denominator, but in this case, as I was telling you, instead of multiplying only by the root that completes me this one, we need to multiply in order to become on the denominator a product of the sum and difference of a binomial, because in that case, when we have a product of the sum and difference of a binomial, because we have only the root squared and the other stuff squared, we will be possible to eliminate the root from the denominator, and that way in my final answer I won't have any roots. So it's going to be almost the same process using the product of the sum and difference of that binomial that will give me a difference of squares, and at the end I won't have any roots. So let's see another example. So in this example, we have something like this. We have two roots on the denominator. Don't worry, it's going to be exactly the same process. Remember, we need to multiply by the product of the sum and difference of that binomial. So it's going to be one that do not change sign and the other one that changes sign. If we put it on the denominator, we need to put it also on the numerator. So what will happen here is that on top we have 6 the square root of 5 minus 2 the square root of 3 that multiplies the square root of 5 plus the square root of 3. And on the bottom part we will have the square root of 5 minus the square root of 3 that multiplies the square root of 5 plus the square root of 3. So let's go first with the denominator part. On the denominator part, it's going to be simple because it's going to be the one that do not change sign squared minus the one that changes sign squared. On the top part, on the numerator, it's going to be a little more complex because we have the multiplication between two polynomials, in this case two binomials. So we need to do all the possibilities. This one multiplying this and this one multiplying this and this. So let's see. The first one is going to be 6, and we have the square root of 5 multiplying the square root of 5 is going to be 5 squared. The second one is going to be plus 6 the square root of 5 times 3, that is 15. Then it's going to be minus 2 the square root of 15. And finally, it's going to be minus 2 the square root of 3 squared. So it's possible to take out something from the first and the last root. So we are possible to take out a 5 on the first. Then it's going to be plus 6 the square root of 15 minus 2 the square root of 15. And finally, minus 2 that multiplies 3. All of it divided by the square root of 5 squared is going to be only 5. The square root of 3 squared is going to be only 3. So it's going to be 30 plus 6 the square root of 15 minus 2 the square root of 15 minus 6. All of it divided by 5 minus 3, that it's 2. So in this case, it's going to be 24. That it's 30 minus 6. Then it's going to be plus 4 the square root of 15. All of it divided by 2. Of course, maybe we can continue factoring because every term is divisible by 2. So our answer is going to be 12 plus 2 that multiplies the square root of 15. So the process is going to be exactly the same on any exercise. The idea is we need to complete the product of the sum and difference of the binomial on the denominator in order to become a difference of squares, and that difference of squares will help us to eliminate if we have one, as in exercise number 1, or also if we have two roots, it will be possible to eliminate both roots if we use the rule of the special product that we have here. After that, we will need to only simplify our answer in order to obtain the one that doesn't have the denominator with roots. So let's see one last example. So imagine we have something like this, 3n minus 2 that multiplies the square root of 3n, And on the bottom part, we have minus 6 that multiplies the square root of 3n minus 2m. Remember, we need to complete on the denominator the product of the sum and difference. In this case, both of them are negative. Remember the rule from the specific product of the sum and difference says that one of the terms do not change sign and the other one needs to change sign. So in this case, maybe the first one won't change sign, it will stay negative, and the second one will change sign. That way we will have one that do not change sign and we will have another one that changes sign. Whatever we put on the denominator, we need to put it also on the numerator part. So what will happen? It's going to be on the bottom part, we will have the one that changes, that do not change sign, all of it squared, minus the one that changes sign, in this case 2m, all of it squared. What will happen on the numerator part? It will be the multiplication of the two of them, this one by this and this one by this and this. So let's do it on a single step. The first one is going to be minus 18m that multiplies the square root of 3n. The next one is going to be 3m and 2m, so it's going to be plus 6m squared. The next one is going to be minus multiplied by minus, it's plus, it's going to be 12 that multiplies the square root of 3n and 3n is going to be 3 squared n squared. And finally the last one, that it's going to be minus 2 that minus 2 multiplied by 2, it's going to be minus 4 m that multiplies the square root of 3n. What will happen here? It's going to be, let's continue doing it, minus 18m that multiplies the square root of 3n plus 6m squared plus 12 that multiplies 3n minus 4m that multiplies the square root of 3n. And on the denominator, it's going to be minus 6 squared, minus multiplied by minus is plus. So it's going to be 36 that multiplies the square root of a power of 2. We can eliminate the square root that multiplies 3n minus the second one squared, that it's going to be 4m squared. What will happen next? It's going to be minus 18m that multiplies the square root of 3n plus 6m squared plus 36n minus 4m that multiplies the square root of 3n. All of it divided by 108n minus 4m squared. So let's see if we have like terms that we can add and subtract. We have this one and this one because both have the same type of coefficient, something with m, and the same root, that is exactly the square root of 3n. So we can add them. And it's going to be, let's start with 6m squared. Then we will have minus 18 minus 4, it's going to be minus 22m that multiplies the square root of 3n plus 36n, all of it divided by 108 minus 4m squared. Everything is divisible by 2, so we can simplify an answer, and it's going to be 54 minus 2m squared, and top is going to be 3m squared minus 11m that multiplies the square root of 3n plus 18n, and that will be my final answer. So it doesn't matter if we have many roots, a single root, everything, the process will be exactly the same. We need to complete the product of the sum and difference of a binomial in order to have a difference squared on the denominator, and that way it will be possible to eliminate every roots we have on the denominator part. So that was it for rationalization with binomial denominators. See you on the next video.